My name is Catherine Gertz, and I teach third grade at the EKP Sitco Innovation Academy in Calcasieu Parish. I'm most passionate about cultivating curiosity in every student. The lesson you're going to watch today is a lesson on magnets. This is an extension lesson. We taught amplify force and motion, and in that lesson prior to this, we discussed maglev train systems and how they work. Now we're moving into the students actually creating a maglev train system. So there were some things that they needed to know in order to make their maglev train system work. This lesson is where they really explore with the magnets. I want them to really understand how magnets repel because their train is going to have to levitate. I also want them to understand how they attract because there is some places where they can place the magnets that will pull the train down the track. This is a discovery lesson. You're going to see the students in a lot of conversation with each other. They're trying to figure out how magnets work. These students then, because they're in these groups, I had to group them based on their academic and their social needs. You're going to see several misconceptions in this that I purposely did not correct because this is just the beginning lesson for the Exploring the Magnets, and we'll have several lessons after this one. I want the students to make these discoveries on their own instead of me giving them the information. This is really what stands apart the students who can really comprehend how the magnets work. If I tell them, they may forget. If they do it, they'll remember. So in yesterday's science lesson, we read a story about Hikaru and how he and his friends got together and designed a maglev transportation system. And they created one. And so we talked yesterday about how I wanted you to be able to create a maglev transportation system. And so today we're going to be exploring magnets and property of magnets so that we can use that when we build and create our own maglev train system. So I want to show you some examples of what it's going to look like. Your maglev train system will have to fit inside this box, okay? And you will design the track on a little piece of manila paper, like this, okay? So you'll just put the magnets on here, the track. It will fit in the bottom. And then there's a little window for you to look through so that you'll be able to see your train levitate, right? Okay. You will get some other things to make your train system. You'll get some foam, you'll get some tape, and you'll get a little cup. And of course, you'll get some magnets. Okay? But before we begin that, we need to think about our question that we're going to try to answer today. And I wrote it on the board. How can we use properties of magnets to help us design a maglev transportation system? So that's what we're going to be trying to figure out today. So I want you to think back to the story, and I want you to think about Hikaru's train. It had 3 parts. Does anybody remember the 3 parts it had? Terry? It had magnets, that's one, very good. Parker? It had a parachute. Ours will not have a parachute though, because it's going to stay inside the box. But it did have magnets, and there was 2 other parts to the system. Evan?
Wheels?
It did not have wheels. Do you remember we said it didn't have wheels? Why did it not have wheels? Bo?
Because it levitates with the magnets.
Because it levitates with the magnets. But it did have 2 other parts. Do you remember the other parts? It had magnets. Christian?
Track?
It had a track. And
It had like the bars with the magnets on it.
it had the vehicle, right, that carried the toy. You're right, Bailey. So it had a vehicle that carried the toy across. So you're going to have to design all 3 of those things. Okay? So, how did it work? How did his maglev transportation system work? Grayson?
You have to give it a little push and you go down the track and it will go into the back.
Yeah, so he would put the vehicle on the track, remember, and he said he would give it like a little push, right? And so you're gonna do the same thing. So you're gonna build the track and the vehicle, and then you'll put it inside the box, and you'll give it a little push. And then it'll float from one side to the other. It'll levitate from one side to the other. Okay? So before we start, I want you to tell me everything you know already about magnets, and I'm gonna make a list on our board about the properties of magnets that we already know. Evan, what's something about magnets you already know?
They're magnetic.
They're magnetic. Christian?
When you put them on opposite sides, they can like levitate.
Okay, opposite sides. Levitate, very good. Ooh, they push and pull each other. Has anybody ever put a magnet close together and you can kind of feel it pull or push? Very good, they push and pull. I like that. Jackfruit. To complete part 2, 3, and 4, I will be walking around if you need any assistance, okay? Yeah, I'll go through both of these.
Draw a diagram of what you When we flip it, it always
Activity. We're going to be doing something called magnetic sailing. And the goal is to get the table tennis ball to move from one side of the basin to the other without touching it. You can only move the magnets on the outside. And you have to get the tennis ball to move from one side to the other side without touching the ball itself. Okay? Now, when we talk about our maglev transportation system, remember it has to move. So we're going to see how we can use magnets to help something move. Okay? Now, you might have some ideas. So I want you to think, and then I want you to make a prediction on your paper.
No, it's totally like here. It used to be
Okay. How'd you know it was the wrong way, Adeline?
Because it was sucking it and then we tried it.
Well, what happened when you tried it the first way?
One way.
What we don't say connected, what do we say? It.
No, you can't do it.
What's the science word when magnets stick together? Attract. What do you think we could use that information for when we're making our maglev train system? Like, how would that information be helpful? Grayson?
Like, we could fit something so, the one side doesn't pull the other magnet to the other side.
Yes, so we're going to be very mindful because how many of you put the foam and the paper in between? Colton, did you do that?
Yes.
Was it able to still levitate? So what does that tell you?
That we could, like,
Does the magnetic field still work even if there's something in between the two magnets?
yes.
How would that be important when you're looking at building the maglev train system? Terry?
Even though something's like in front of it, it still levitates because if like you put something between like rotating magnets, that will be good because it still levitates.
And then I saw several of you working and you were stacking the magnets on top of each other. Did that increase the amount of the levitation or did it decrease the amount of levitation? Bailey?
Kind of decreased it
When you had two magnets on top or two magnets on bottom?
on top because it would put the weight down on top, but at bottom it would make it higher because it's stronger for the base.
What does that tell you about magnetic fields? That it can be what?
Stronger.
Stronger. So do you think that might be important when you start putting your maglev train system together?
Yes.
Yes, because if you need it to levitate more, what would you need to do?
We could add another magnet.
Yeah, if you need to have a stronger force, you may have to add more magnets to make a stronger force.
But we would have to put them on the bottom because, like Bailey said, if we put them on the top, it will weigh it down.
It might weigh it down.
I put a hole in the box at the end in the beginning and like kind of get the magnets to go in there and put a magnet on each side of my magnet train and make it to where those two magnets on the train and the side would repel and it could push by itself.
Sort of like what you did in the sailing
Yes,
one.
it would go by itself.
Okay, so what did you learn in the sailing one that might help you in your design? Carter?
I learned that if you add more weight to
put all the magnets together, it would repel that magnet across
way faster.
way faster. So that tells you something about the magnetic
because
force, right?
All of them together have a stronger force that could push it.
Oh, okay.
And also, like, okay, so we might need, I might want to put more than one on one of the sides because, like I also learned, when you added more to repel, it would go faster across. So if I added more to repel the train, it would go faster across like a real.
Like a real train. Okay, Adamy?
For the ping-pong ball thing, my group would put four on each side. One was repelling and one was attracting.
Oh, so you put one group of 4 magnets repelling and one group of 4 magnets attracting. How well did that work?
Really well.
Really well. Okay, so now I want us to think about the different properties of magnets that we've talked about today and see which properties are important for helping us as we begin to design our maglev train system. Which properties would be most important? Bo?
Oh, that they push and pull.
Push and pull. Or repel and attract. Very good. So the fact that they push and pull or repel and attract, we say that's very important, right? So that we can use that property of the magnets, right? And Elijah, you asked me a question during the experiment about each magnet. What'd you say?
That is
You asked about the poles. He said, does every magnet have a north and a south pole? What do y'all think? Does every
Yes.
what'd you say?
There wasn't a way to tell if there was.
Oh. So do you think it would be important for us to do another experiment to kind of tell if we could figure out a way to tell the magnets north or south?
All it says it says north and south pole.
We
Track.
could
So
put
if they
colors
attract,
like
we know
in
one's
and
north
X.
and one's south.
Right. So then what you're saying is in order to build the design, we need to know north and south. We need to be able to identify
Or we could just label which side's which.
the north and the south pole, right? Because we need to know which side to put the magnets on, because if you put the magnets, a north and a south side together, are they gonna repel?
No, it's
No.
gonna attract.
It's gonna attract.
And stop.
So
Right.
if we see that it attracts, one has to be north or one has to be south. So if they attract, they're either one's south and one's north. But if they repel, one has to be like north and north or south and south.
Very good. What are some other questions that we still have left to investigate before we can build, right? So I think for today's lesson, we did a great job. I think that we were able to find some properties of magnets that will be helpful when we build our maglev train systems. We still have a couple of questions to investigate. Okay? Okay, so that's all for today's lesson. Please go back to your seats. In this lesson, the objectives were met. The students did a phenomenal job exploring magnets. One of the things that I would do differently next time would be maybe give them less time on the levitating magnets. It seemed like we got to that point and then they kept doing other things, which was good in the explore part. But I could have cut that down a little bit and had more time on the sailing magnets where they could have repelled across the basin. The reason I know that these objectives were met is during our debrief. The students had a really good understanding of attracting and repelling, and they also had further questions. Those questions were written on the board, and then we will be going into those next. One of the questions was about the strength of the magnet. Can they put 2 magnets together, and if they do, does that increase the strength? Several of them already saw that, but they weren't sure exactly how it worked or how to explain it. Also, they wanted to know about the poles. If it's not labeled on the magnet, how do they know which pole they're working with? This will also be done in a separate lesson. Students will have the ability to check the poles and the strength. All of these things are going to be important in order to make their maglev train system work.